Our universe is a vast and mysterious place, filled with wonders that boggle the mind and stretch the limits of our imagination. It's full of stars, planets, and galaxies, each with its own unique story and characteristics, all part of the grand cosmic tapestry. But, have you ever wondered where it all came from? What is the origin of this magnificent universe we call home? How did it all begin? These questions have fascinated humans for centuries, driving us to explore and understand the cosmos. Scientists believe that the universe began with a massive explosion called the Big Bang, a moment of unimaginable energy and potential. Imagine everything in the universe packed into a tiny point, smaller than an atom. This singularity contained all the matter and energy that would ever exist. Then about 13.8 billion years ago, this point began to expand. This expansion was rapid and immense, setting the stage for the universe as we know it. It's been expanding and cooling ever since, evolving into the complex and diverse cosmos we observe today. The Big Bang wasn't just any explosion, it was a unique event that marked the birth of everything we see and know. It was the beginning of everything: space, time, matter, and energy. From this singular event, the universe began its grand journey. It's hard to imagine, but before the Big Bang, there was nothing. No stars, no galaxies, no space, no time, no space, no time, nothing. The concept itself is almost beyond human comprehension. The Big Bang Theory is the best explanation we have for how the universe began. It's a cornerstone of modern cosmology. It's supported by lots of scientific evidence, including observations of cosmic microwave background radiation and the expansion of the universe. Understanding the Big Bang is crucial to understanding the universe we live in today. It helps us grasp the origins of everything around us and our place in this vast cosmos. In the first fraction of a second after the Big Bang, the universe was incredibly hot and dense. It was so hot that matter couldn't even exist in the forms we know today. Everything was pure energy. As the universe expanded, it cooled down. This cooling allowed matter to form from the energy, like raindrops condensing from steam. The first atoms, mostly hydrogen and helium, formed when the universe was about 380,000 years old. It was like the universe was finally taking shape. This early universe wasn't the beautiful tapestry of stars and galaxies we see today. It was more like a cosmic fog, with atoms spread out over vast distances. But within this fog, the seeds of future structures were already being sown by gravity. Gravity is a force that pulls things together. It's one of the fundamental forces of nature, and it plays a crucial role in the formation of stars and galaxies. Without gravity, the universe as we know it would not exist. Over millions of years, gravity pulled the hydrogen and helium atoms closer and closer. These atoms, which were formed in the aftermath of the Big Bang, began to coalesce under the influence of gravity. The process was slow and gradual, but relentless. These clumps of gas became hotter and denser. As the gas clouds contracted, the pressure and temperature at their cores increased dramatically. This intense heat and pressure were the precursors to a remarkable transformation. Eventually they became so hot and dense that nuclear fusion began. Nuclear fusion is the process by which atomic nuclei combine to form a heavier nucleus, releasing a tremendous amount of energy in the process. This is the birth of a star. This is the process where atoms fuse together to create energy, and it's the same process that powers our sun. The energy produced by nuclear fusion radiates outwards, balancing the gravitational forces pulling the star inward. These first stars were massive and short-lived. They burned through their nuclear fuel quickly, shining brightly but living only for a few million years. Their short lifespans were marked by intense activity and dramatic changes. When they died, they exploded as supernovae, scattering heavier elements into space. These supernova explosions were among the most powerful events in the universe, capable of outshining entire galaxies for brief periods. These elements would eventually become the building blocks for planets and even life itself. The carbon, oxygen, and other elements essential for life were forged in the hearts of these ancient stars, and spread throughout the cosmos by their explosive deaths. Gravity continued to shape the universe, pulling together stars to form galaxies. These galaxies became the large-scale structures of the universe, each containing billions of stars bound together by gravity. Galaxies are vast collections of stars, gas, dust, and planets. They come in various shapes and sizes, from spiral galaxies like our Milky Way to elliptical and irregular galaxies. Each galaxy is a dynamic, evolving system. Our own galaxy, the Milky Way, contains billions of stars, and it's just one of billions of galaxies in the observable universe. The sheer scale and complexity of the universe are mind-boggling, and it all began with the simple force of gravity pulling atoms together. We've learned a lot about the universe by observing light from distant objects. One important discovery is that the universe is expanding. How do we know this? Imagine the sound of a car engine. As the car moves away from you, the sound of the engine seems to stretch out or become lower in pitch. This is called the Doppler effect. Light waves can experience a similar effect. When an object in space is moving away from us, the light it emits gets stretched out. This stretching makes the light appear redder, and it's called redshift. By observing the redshift of light from distant galaxies, astronomers discovered that most galaxies are moving away from us. And the farther away a galaxy is, the faster it's moving away. Section 5. Measuring the Universe, Hubble's Law. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. He found that there's a relationship between a galaxy's distance and its redshift. This relationship is known as Hubble's Law, and it's one of the most important concepts in cosmology. Hubble's law tells us that the universe is expanding uniformly. It's like baking a loaf of raisin bread. As the bread bakes and expands, the raisins move farther apart from each other. Hubble's law allows us to measure the rate of the universe's expansion, which is called the Hubble constant. It's a number that tells us how fast the universe is stretching. By understanding the Hubble constant, we can estimate the age of the universe and learn more about its history. Section 6. Dark Energy and the Accelerating Universe. For a long time, scientists thought that the expansion of the universe was slowing down due to gravity. However, in the late 1990s, astronomers made a startling discovery. They found that the expansion of the universe isn't slowing down, it's speeding up. This discovery was like throwing a ball up in the air and watching it accelerate upwards instead of falling back down. Scientists believe that a mysterious force called dark energy is causing this acceleration. Dark energy is a form of energy that seems to be pushing everything in the universe apart. We don't know much about dark energy yet, but it's one of the biggest mysteries in modern science. Section 7. The Hubble Space Telescope. Our eyes on the cosmos. The Hubble Space Telescope, named after Edwin Hubble, has been orbiting Earth since 1990. It's like a giant, powerful telescope floating in space. Because it's above Earth's atmosphere, which can distort light, Hubble can see distant objects with incredible clarity. Hubble has revolutionized our understanding of the universe. It's captured breathtaking images of distant galaxies, nebulae, and star clusters. Hubble has also played a crucial role in measuring the universe's expansion rate and studying dark energy. It's a testament to human ingenuity and our quest to explore the cosmos. Section 8. The Future of the Universe. What does the future hold for our universe? This question has fascinated scientists and philosophers for centuries. As we gaze into the night sky, we can't help but wonder about the fate of the cosmos. Will it continue to expand forever? Or is there an end in sight? The universe has been expanding since the Big Bang, and this expansion shows no signs of slowing down. The answer depends on the balance between the outward push of dark energy and the inward pull of gravity. Dark energy, a mysterious force, is driving the accelerated expansion of the universe. If dark energy continues to dominate, the universe will likely expand forever, becoming colder and darker over time. Stars will burn out, galaxies will drift apart, and the cosmos will become a vast, empty expanse. Galaxies will move farther apart, and eventually, we might not be able to see any other galaxies from our own. The night sky would be devoid of the familiar twinkling lights we see today. However, there are other possibilities. The future of the universe is not set in stone, and there are many theories about what might happen. Some scientists speculate that dark energy might change over time, perhaps even reversing its effects. This could lead to a scenario where the universe stops expanding and begins to contract, or that there might be other forces at play in the universe that we don't yet understand. These unknown forces could alter the fate of the cosmos in ways we can't currently predict. The future of the universe is an active area of research, with scientists around the world working tirelessly to uncover its secrets. They use advanced telescopes and cutting-edge technology to study the cosmos. and new discoveries are being made all the time. Each new piece of information brings us one step closer to understanding the ultimate fate of the universe. The journey of discovery is ongoing, and the future remains as vast and mysterious as the universe itself. Section 9. Conclusion. A universe of discovery. The universe is a vast and awe-inspiring place. From the Big Bang to the expansion we observe today, our universe is full of wonder and mystery. By studying the cosmos, we gain a deeper appreciation for our place in the universe and the forces that govern it. The journey of cosmic discovery is far from over. New telescopes and technologies are constantly being developed, allowing us to peer deeper into space and unlock more secrets of the universe. The more we learn, the more we realize how much more there is to discover. So keep looking up, keep asking questions, and never stop exploring the wonders of the universe.